Hey coach, what we got for you today is using a motor driver. So we start with two LEDs that we power using the 7 and 8 pins. And so the power runs through two 100 ohm load resistors to the LEDs, and they run to ground. And also ground runs all the way through here. As well, we have 3.3 volts powering this whole side. And we have 5 volts powering this side over here, which actually is used to power the motor. And so, as well, we have a potentiometer, which is connected to A0, and that is powered through 3.3 volts. And we also have a piezo buzzer, which is connected to pin number 9, and is powered through pin number 9. As well, we have the motor driver itself, and it is very can be complicated. So we start with this orange wire right here, which is connected to pin 4, and that is actually the motor A connection. Next, we go to the purple jumper wire, which is pin number 5, and that is the motor B connection. And then we go to the blue cable, which is pin number 6, and that is another motor B connection. And the last one down here goes to ground. As well, on the other side, we have the first one down here is ground. The next one, the motor speed, it actually controls through this red wire that goes directly to the motor. And the black wire controls the direction of the motor. As well, we have this green wire connecting to the third one down, which is another direction pin, as well as the 3.3 volts connection to the second one down, which is another direction pin, and the top one right here, which is connected to a 5.0 volts, is the speed of one direction of the motor. Alright, so here's the code for the motor driver. We start by setting all of our integers, and it also helps us set the pins. We also begin the serial monitor so we can use that, and we set everything as outputs. Down here, we're going to read the sensor value, which is the potentiometer, and so we just make since the potentiometer value reads, we just divide it by 4, because the potentiometer value reads out of 123, and then we just add 4, because then we just add 4 to it. It just creates a value for the PMW that only goes up to 255. And then down here we have set goes in here, it goes in the first direction. That's 1 to high and the other direction to low, because if we set both to high, it would just break the motor, and that would not be too good. And then also here, we're gonna write out the PMW, which is the speed of it, and the piezo plays a tone of 250 frequency, and it delays for a whole second. We also serial print direction 1, and we turn the green LED on. We take a second delay, and then we put both on low, so we stop it. PMW is set the value of it, and then put the red LED on. Print that out, delay a second. Then we set the next direction to high and the other one to low, so now it's going the other direction as before. We set the speed of that, serial print the direction 2. Now the green LED is back on because the motor is turning again, and we set the piezo to a much higher frequency. It just makes a different noise of 989. Then we stop both, right stop, and now the red LED is back on, and we delay, and then the whole loop runs over and over again. So here's the program actually working. And so right there you can just hear it going. You hear the motor going. I just put a piece of duct tape on the end so you can tell that it is spinning in different directions. You can also tell from right here the motor spins in different directions there. It goes green, then whenever it stops the light turns red. As well, the potentiometer will change the speed, so if we spin this up, it'll go really fast. So we'll just tone it down a little. And then we put it down really low. It goes very low as well. As well, here are the printouts. Direction 1, green LED goes on, then it stops, red LED goes on, and direction 2, green LED, and it just keeps going in that pattern as the program does. And as always, thank you for watching.